Hello everyone. Now we are at test case design techniques part, right? So already we have completed boundary value analysis. Guys, now we'll see what is equivalence class partitioning test case design technique. Okay, guys, the name itself is saying that we need to partition the test cases. We need to partition the test cases, right? Now, equivalence class partitioning is a software testing technique. This I already explained. Okay, so now equivalence class partitioning is a test case design technique. While designing the test cases, same test cases we execute. Okay, same equivalence class partitioning test cases we execute, so that this can be called as testing technique as well. So boundary value analysis and equivalence class partitioning testing will comes under functional testing. Why? Because we are validating the functional requirements here. So these testing techniques that involves dividing input data of a system into groups. You can divide it as a partitions, or you can call it as a groups or classes. Okay, based on the certain characteristics or attributes, like whatever the signal values you have, based on the signal values, how you are designing the partitionings and all, right? Now the goal is to reduce the number of test cases. The equivalence partitioning test case design technique goal is to reduce the number of test cases while ensuring that each group is representative of a set of similar conditions. So each partition shall have the similar conditions. Let's say, for example, 0 to 50 values you are making as one partition. So these 0 to 50 values should give the same output, right? I'll explain you that. Okay. By testing one or few values from each equivalence class, testers can gain confidence that the entire class behaves similarly. These testing techniques particularly useful when dealing with large number of possible inputs. Okay. Now, guys, here you see example I have taken a fuel level of a vehicle. Okay. The conditions. There are three conditions, guys. Okay. This condition will give one output. This condition will give you other output. This condition will give you other output. Okay. So one, fuel must be between 0 to 100 liters for normal operation. What they are saying is the fuel must be between 0 and 100 liters. The fuel must be between 0 and 100 liters. So you should have 1 liter to 100 liters for normal operation, so that you can drive your vehicle. Okay. Now, if the fuel drops below 10 liters, so if you have 9 liters of fuel in your vehicle, then a low fuel warning should be triggered. Second condition, if the fuel level reaches to 0 liters, the vehicle cannot operate. Okay. Now guys, these are three conditions. For three conditions, I have to divide test cases into different partitions. Okay. See, now we have 0 to 100. Okay. We can't apply the value of 1 liter and check whether it is in normal operation mode. 2 liters, check whether it is in normal operation mode. 3 liters, whether it is in normal operation mode. It will be very difficult. It cannot reduce the number of test cases, right? So, what we have to do is we have to divide these values into partitions. Okay. So, each partition is representative of a set of similar conditions. Let's say, for example, now you are dividing one partition from 10 to 20. So if you apply fuel level value as 10, your vehicle should be in normal operation mode. 11, normal operation mode. 12, normal operation mode. Until 20, normal operation mode. So if you apply the values from 10 to 20, it gives the same output saying that vehicle is in normal operation mode. Okay. So these set of similar conditions, you have to make it as a partitions. Right. Now, for these three conditions, I have designed test cases. We'll see how these test cases has been designed. Okay. Now, here's I am taking test case with fuel level 11 to 50. Why I have taken 11 to 50 here? The fuel must be 1 liter to 100 liters. In between 0 to 100 liters, maybe 0.5 liters or 1 liter or 100 liter, whatever it may be, right? So, why I have taken 11 to 50 here? 11 to 50, I made it as a one partition. Why 11 to 50? Why not from 1 to 50? Because if it is below 10, if the fuel level is 1 liter, 2 liter, up to 10 liters, it has to give the warning. Okay. But now what I am checking here, I am checking something of normal operation mode, but I am not checking any warnings here, right? So that in first partition, I have taken values from 11 to 50. These are the valid fuel values. Okay. So 10 to 100, I divided into two partitions. One is 11 to 50. Other one is 51 to 100. These are all the valid values. If you apply from 11 to 50, it is one set of group. It is a set of similar conditions. Okay. If you apply 11, if you apply 20, if you apply 30, if you apply 50, the vehicle should be in the normal operation mode. See, this test case checks the system's behavior with a fuel level within the range of 11 to 50 liters, representing a normal operating condition. Okay. Now this is one partition. You can validate from, you can apply any random values. You can apply 11, you can apply 15, you can apply 25, you can apply 48, you can apply 47. Whatever the value randomly you pick, you apply. Okay. So that if all the random values are working properly, which means by testing one or few values from each equivalence class, by testing one or few values from each equivalence partition, testers gain confidence that entire class behaves similarly. So if you pick randomly 15, 20, 25, 30, you have validated four values, one or few values you have validated, but now you got a confidence that, okay, now all the values will give the same output. Okay, now this is the first partition. Okay, this is the second partition, right? Now in this second partition, what I am validating, how I am designing the test case with fuel level 51 to 100. Okay, valid values. So similarly, the test case covers the system response of a fuel level within the range of 51 to 100 liters, still within the normal operating range. Okay, now this is the second partition. Now third partition, guys. Third partition means, look at here. Below 10 liters, I need to validate. Third partition, below 10 liters, I need to validate. This also I have divided into two partitions. Okay. One is 1 to 5. Actually, you need not to divide this into two partitions. Only one partition is enough. But just to give you understanding of partitions and all, I have divided it into two partitions. Okay. Test case with fuel level 1 to 5. So if you apply values 1 liter, 2 liter, 3 liter, 4 liter, up to 5 liter, low fuel warning should trigger. Now, same 6 to 10, low fuel warning should trigger. Okay. Now, another one, last one, what we need to test is test case with fuel level 0. So, if the test case with fuel level 0, out of fuel, out of fuel, this test case examines how the system handles a fuel level of 0 liters, representing the condition wherein vehicle is out of fuel. So, test in this test case, it will check how the system handles the fuel level of 0 liters. If there are 0 liters, representing the condition where the vehicle is out of fuel, so the vehicle should not operate. Now, invalid value also we need to check. Okay, give the fuel level as -5. Okay, this is invalid fuel value what you can give. Okay, valid fuel values are from 0 to 100, but you are giving -5. And check if it gives the negative value, invalid fuel level, which means negative value falling outside the expected operating range. Okay, so if you give the invalid value, then you check how the vehicle is operating, how the system is operating this fuel level. If you give -5 values, this negative scenario also we need to cover. If you want, you can again make it as a partition from -5 to -10. You can give from -5 to -10 and you check how the system is behaving if we give the invalid fuel level values. Okay, guys, this is how one test case you can divide it into partitions. Okay, so you have to divide the test cases into partitions and you have to develop the test cases in this way. Same test cases can take up for the testing. Okay, so in testing, again, you have to use the testing technique of equivalence class partitioning testing technique to validate all these values. Okay, guys, this is more about equivalence class partitioning test case design technique. I hope you have got understanding. So now you people are able to write the test cases for equivalence class partitioning test cases, right? Yes, that's it. That's it in this video. Okay, in the next video, I'll explain you the rest of the test case design techniques. Okay, okay, guys. Until then, take care and bye.